して、マニエル・デンキーさんの、発表で、AP コースです。タイトルは Evaluation of Nitrogen Fixation Potential of 3 Soybean Genotypes Using Rhizobia Species。ではお願いします。
I introduce I'm from Kenya. I'm from Kenya, a country centrally located along the equator. And within Kenya, we have, as you can see, that's the map of the world. We have Kenya. And within Kenya, we have Busia County, and the Busia County has some constituencies. That's where I come from. And in Busia County, we produce some major crops like maize, beans, sweet potatoes, cassava, soybean, sugarcane, and cotton. And soybean production is still very low. And some of the major challenges affecting farmers in Kenya generally, we have the high cost of farm inputs, we have the climate change, limited access to credit facilities, and deterioration of soil nutrients, and mostly the nitrogen. And also we have over-reliance on rain-fed agriculture, pests and diseases, inadequate research and development, and poor transport system. And the adoption of soybean production can solve the problem of high cost of farm inputs and deterioration of soil nutrients. And let me give some characteristic features of soybean. Its economic and nutritional and functional importance warrants due attention, especially in Kenya. And it's a little crop with ability to fix nitrogen and thus used to improve soil structure and also soil fertility. It has a high protein content of 40% and oil content of 20% that have essential amino acids and unsaturated oil respectively. So it's a solution to increasing lifestyle diseases as per the recommendation from nutritional experts. But the most important thing is that inoculation of soybeans with appropriate rhizobia bacteria provides high number of viable effective bacteria to the rhizosphere to allow for rapid colonization and nodulation. So the objective of my study was to evaluate the effects of symbiotic nitrogen fixation using the variety of rhizobia on selected Kenya's soybean genotypes. And some of the specific was to evaluate 10 rhizobium species for their symbiotic effectiveness with 3 soybean genotypes in plant growth chamber, which is laboratory, on growth parameters and nodulation, and also in greenhouse, also on growth parameters and the yield. And the finals was to identify the best rhizobium strains for each soybean variety for inoculation. And let me move to my research design. As you can see the research design here, I have the soybean varieties, the Gazelle, SP19 and SP3, which was inoculated with Rhizobium diazoefficiens, Japonica, and Elkani. And these are the specific species for each of these rhizobiums. And the target was to increase on yield, chlorophyll concentration, and nitrogen activity, which shows the effect of nitrogen fixation, because those are the major indicators. But the first important part was, the critical part was on bacterial culture, which was supposed to be consistent in all the experiment. As you can see, the rhizobium, this bacterial culture is a slow growing, it has a slow growing nature, and it must be cultured for a long period. As you can see from here, it was transferred for 10 days and for another 10 days also in 100 ml of HA media, which come to a total of 20 days. And after that also it was suspended and measured in spectrophotometer, so that to achieve the correct or to achieve consistent concentration of bacteria. And after inoculation, each plant was inoculated with 10 ml of the bacteria. It was placed in the growth chamber for 28 days. after 28 days, nodules were removed and placed in the vials, the vials, and also the gas, acetylene gas, was also injected inside and placed for 30 minutes. And the nitrogenase within the nodules was responsible for reducing acetylene to ethylene. And that reduced gas, we were able to now measure using the gas chromatography. And that gas can give us just how the extent of nitrogen fixation. And I will go direct to the results. And on the results, I will start with gazelle soybean variety. And I will just give a result of correlation, which is the last part of the data analysis. And according to the results, we have some positive correlation, which means high nitrogenase activity was due to high nodule number, which resulted to high nodule and plant dry weight, according to the results. So the second step I was supposed to do is now to identify each and every individual rhizobia strains which has this characteristic. So my speculation was rhizobia strains with the stated effect on nitrogen fixation was the best for this variety. I went straight to analyze on nitrogenase activity, which is the effects of rhizobia inoculation on acetylene reduction activity and nodulation on gazelle soybean variety. On the first part, I just highlighted the shoot and roots of the least performers and the two which are the best performers. And on part B, it gives now the nanomole per hour per plant, which is the nitrogenase activity measurement, and each individual rhizobia strain. And also, I also placed this one is the number of nodules, which gives the nodulation. And according to this data, I highlighted some of the specific rhizobia strains which has high effect of nitrogenase activity. I went ahead also to consider other parameters which effects of rhizobia species inoculation also on soybean parameters, whereby here we have several parameters, plant parameters, and here we have the treatment. And in the treatment, we have the section of efficiency, japonica, and L-cani. And some of the highlighted parts, it shows where there was high effects on nitrogen fixation. And this analysis, I used the one-way ANOVA analysis. And on this, I highlighted some of the specific rhizobia strains which has high effects on this gazelle variety. Let me move also to another variety, which is SP19. And according to the results from the correlation results, it shows that high nitrogen fixation, it was due to high nodule number, which induced high plant and nodule dry weight, and nodule diameter and shoot height. So according to my speculation, is that the strain with the stated effect was the best soybean variety for it. It was the best for this soybean variety. And also I checked on nitrogen activity, like the first one. And also I highlighted some of the specific rhizobia strains which has high effect on nitrogenase activity and nodulation. A good example is B. L-cani USDA 94, B. L-cani USDA 61, and B. efficiency USDA 122, which was with high effects on nitrogenase activity in this variety. And also I checked also on other parameters, whereby according to the other parameters, there was high effects on efficiency, japonica, and also on L-cani, according to these results. This is the last variety, which is SP3 soybean variety. And there was some correlation between 4 parameters. And according to this correlation, I concluded that high nitrogenase activity was due to high nodule number, which resulted to high plant dry weight. So my speculation also was on the strain with this stated effect was the best for this soybean variety. And also I checked on nitrogenase activity. I compared some of the least performers and the best performers on the shoot and the roots. And also I checked on the nitrogenous activity and on the nodulation. And according to this information, also the L-carni, japonica, and also diazodeficiency has some effects on this soybean variety. On this table also, it gives some of the effects according to the parameters and the treatment. And in these results, diazodeficiency, it has less effects. And japonica and L-carni has some high effects on SP3 variety. And also I highlighted some specific rhizobia strains which has direct effects on this soybean variety. And the variety responds well to rhizobia strains of japonica and L-carni. And also to make the conclusion about all of this, I had to do what we call the ranking performance, where I do some ranking of different rhizobia strains based on the effects of soybean performance, whereby 1 and 10 being the lowest and the highest ranks respectively. According to highlighted rhizobia strains, it shows that they are the best for gazelle, SP19, and also SP3. I went also ahead also to see some of the effects of rhizobia species inoculation on chlorophyll concentration. I highlighted here we have the soybean varieties and concentration, measurement of the chlorophyll concentration of all the leaves. And according to this data, it shows that B. japonica has high effects on chlorophyll concentration on all the soybean varieties. And also I checked on the yield. I compared some of the yield, where we have also the gazelle, SP19 and SP3 and corresponding yield. And on the yield, we have seeds weight in grams per plant. And those are the effects of specific rhizobia strain. And according to this, it shows that all the three varieties and effects of each bacteria strain on each variety, it has some individual effects. Like for SP3, there are some L-carni, which has some individual or specific effects on the variety. And also on this table, also it summarizes all the parameters and also the effects on the treatment. And according to these results, it shows that the gazelle variety has high effects on B. japonicum USDA 60, and SP19 variety has B. japonicum USDA 38, and SP3 has B. japonicum L-carni USDA 760. And also I did also ranking performance. And according to the ranking performance, I used 4 key parameters. And these are the best for gazelle. And also SP19, those are the best for SP19. And also for SP3, those are the 3 best for SP3 variety. But before making the final conclusion now, I had to compare. I had to make some comparison of nitrogenous activity, the yield, the chlorophyll concentration per plant, and the gazelle variety. For gazelle variety in the growth chamber, the greenhouse, and also this one is from the greenhouse and the greenhouse. And I picked only B. japonicum strain. According to B. japonicum, in the laboratory it is high, but when it comes to the greenhouse, it is low. When it comes to the yield, it is high. At the same time, chlorophyll also it is high. When we come to SP19 variety, I picked one of the strain, one of the rhizobium diazodeficiency, and when in the laboratory it is low, but in the also greenhouse the effect was low, but when it comes to the yield was high, and the chlorophyll concentration was low. And for the SP3 variety, in the laboratory, the effect of nitrogenous activity was high in L-carni. Using the L-carni, it was high. But in the greenhouse also, the L-carni was high. In the seed yield also, it was high in the greenhouse. And chlorophyll concentration also, it was high. So when making the final decision, I had to consider these factors. And in summary, After analyzing all those performance analysis and ranking, the best compatible rhizobia strain for each variety were as follows. For Gazelle, it was B. japonicum USDA 60, B. japonicum USDA 123, B. efficient USDA 122, and for SP19 variety, it was B. japonicum USDA 60, B. japonicum USDA 38, and B. elkani USDA 760. And also for SP3 variety, we had USDA 760, USDA 760, and japonica USDA 60, and efficient USDA 110. And in conclusion, Gazelle genotype responds well with B. japonicum strains, and SP3 genotype has an effect on Rhizobium elkani. And soybean plants inoculated with Rhizobium strains enhanced nitrogenous activity in the nodules, which contributed to increase in nitrogen fixation and assimilation in plants. And there was significant interaction between each variety and specific Rhizobium strain. And B. japonicum USDA 123 has high effect on nodule number for both Gazelle and SP3. Thank you.
そうしましたら、今の発表に関しまして質問をお願いします。
It's very interesting, many data. So, you think best species is was B. japonicum USDA 60 is a very good result. It looks like. So, do you know what difference is in japonicum USDA 60 and, for example, japonicum USDA 1, 2, 3 is gene difference of genetic data, or do you know something information?
Yeah, the question in terms of where the difference comes about, like for japonica USDA 60 and japonica USDA 123, where the difference comes about is in terms of the nucleotide, because what differentiates all these Rhizobium strains is in terms of the arrangement of the nucleotide, and also even in terms of the sizes.
What percent of, for example, 99% identity or some information is?
Maybe inside the molecular part of it, I might not be in a position to answer the molecular part of it, especially in terms of percentage of nucleotide difference.
Thank you for your presentation. For various soybean detailed investigation was done. It was very interesting. I have one question. You grow plants in growth chamber or greenhouse. Do you think that the evaluation in growth chamber or greenhouse is the same as the evaluation in the field?
According to these results, the results from the growth chamber and also the results from the greenhouse, it was not consistent. Maybe because of the various factors which affect the nitrogen fixation. And also for me, according to my recommendation of speculation, also when it comes also to the field, also I speculate that it might not be the same. So even according to my recommendation is also the same experiment to be done in the field, because the results from the growth chamber and the greenhouse, they were not the same.
Thank you. そしたら時間になりましたので、これで終わりにしたいと思います。